Hello everyone, welcome back to my channel CAD Voyager. This is me, Mayanka Chattopadhyay, and today I am back with another problem of quant. So this is a problem of coordinate geometry from the CAT 23 slot 1 paper. It has given you an equation of a circle on the xy plane. You can see the equation. It has also said that L is the locus of the point of intersection of a pair of tangents to the circle, and then it has given you a condition that those two tangents make an angle 60 degree between themselves, and the question has asked you the point at which L touches the line x equal to 6 is which point. So there were 4 options given in the paper, but for now I have eliminated, I have not kept those options. So let's get started by solving the question. So first let's understand how do we look at an equation of a circle on the xy plane. Here you can see the equation is given by x square plus y square plus 4x minus 6y minus 3 equal to 0. Now how does a general equation of a circle on the xy plane look like? It looks like something like this: x minus a whole square plus y minus b whole square equal to r square. What is the meaning of this on the xy plane? Suppose we have x-axis here and y-axis here. Now this equation means that the center of the circle is a point a comma b. So if we take measurement a, this is your point a comma 0, and if we take a distance of b on the y-axis, this is your point 0 comma b, then this point a comma b becomes the center of the circle whose radius is given by r. Something like this. This is your r. So first what we have to do is simplify this equation in this form. So we need two square terms and a plus sign between them, and hopefully we get a square term on the right hand side by rearranging everything. So let's start by doing, we already have x square, we have 4x. Now 4x can be written as 2 into 2 into x. To complete a whole square term we need another square, that is your 2 square or 4. The next thing is y square minus, we have 6y. 6y can be written as 2 into y into 3. Like the previous one, to complete the square we need a square term, and that is your 3 square or 9. So how much do we have up till now? This is 4 and this is 9. We already have 13, but we need to have a constant term which is minus 3. So what would we do? We would subtract 16 from here, this everything total, and that is your equal to 0. So now we have x plus 2 whole square plus y minus 3 whole square equal to 16. 16 means 4 square. There we have it, and like r square term. So what is your r, or the radius of the circle, is 4. Up till this informations we have now. Now let's understand what is the meaning of a locus. So a locus can be defined as something like a curve made by all possible values of a point on the xy plane that satisfy a given condition. What is the given condition here? for example, in this question, the given condition is that the two tangents make an angle of 60 degree within themselves, and we have to find the locus of the intersection point of those two tangents. So suppose we take that this equation, the circle looks something like this, and we have two tangents to the circle. They make an angle of 60 degree within them. So this is suppose a point, your A1. Similarly, we could have drawn two tangents like this, and they also might have made an angle of 60 degree within them, and let's name this point A2. Similarly, another can be like this. This is 60 degree and this is A3. So by intuition, you might see that we can get infinite number of points which satisfy that similar condition, like this A1, A2, A3. We could have had another points like A4, A5, A6, A7, and like this. All those points would have lied on this curve. And what kind of curve is that? That is also a circle. So like for example, we could have had these two tangents, we could have had these two tangents, like these two tangents. All the intersection point of all these tangents would have lied on this curve. Okay, so we understand up to now that if this is my circle C, this would be our locus L. Okay, now let's forget for once that this is a coordinate geometry problem and look it from the angle of a simple Euclidean geometry problem, or a trigonometry, you can say. We have a circle like this, we have two tangents, this angle is 60 degree. Now let's drop a perpendicular from the center of the circle C. You know that the radius of the circle and the tangent passing through the point of the radius of the circle that cuts the circumference of the circle, they are perpendicular to each other. So this is 90 degree. Let's also construct this. This is also 90 degree. So if we take these two triangles, let's name them A, B, C, D. So if we look at triangles A, B, C and A, C, D, the angles of these two triangles are exactly equal. Like this is 90 and this is also 90. This side is common to both the triangles, and as these two are the radius of the circle, these sides of the triangles are also equal. So these two triangles are similar or congruent, you can say. That means this angle is 30 degree, this angle is 30 degree. It has to happen. So now you have a triangle whose this angle is 90 degree. This is the radius of the circle. We already have seen the radius of the circle as 4. We have to find this distance. Now what is this? If we look at this picture, let's name it in similar terms. This is A, B, C. This is also your A, B, C. So what is your BC? your BC is nothing but the radius of the larger circle, or radius of the circle given by L, right, the locus. So simply apply this, this angle is 30 degree, so you can simply apply what is sine 30. Your sine 30 is equal to half, that is equal to this side AB by your BC, or your AB is 4 and your BC you have to find. So from here we can see that BC equal to 8. Now we had the equation of the circle. We found out the equation was something like this: x plus 2 whole square plus y minus 3 whole square equal to 4 square. We had the information that the radius of the circle is 4 and the center of the circle is at minus 2 comma 3, this and this. So let's try to visualize this thing. Let's try to draw an approximate picture of this. This is your x-axis, this is your y-axis. Where is your minus 2? Let's somewhere like this region. So this is your minus 2 comma 0. And where is your other point? That is 3 distance on the positive direction of the y-axis. This is your 3 comma 0. So the center of the circle is at minus 2 comma 3 and the radius of the circle is given by 4. That means 4 distance from here. This is somewhere like this and this. So a portion of your circle might look something like this. Something may be like this. Okay. Now the question has said, at the last you can see, then the point at which L touches the line x equal to 6. So let's take x equal to 6 at something at somewhere here. This is your x equal to 6 line and this point is your 6 comma 0. Now your locus, we found out that the radius of the locus was your 8, or the radius of the larger circle is 8, and the question has asked where does that larger circle or the circle L touch this particular line. So let's calculate the distance of this line from the center of this circle. The center of this circle is at minus 2 comma 3 and your this point, suppose if we drop a perpendicular from here, your this point is at 6 comma 3. Can you see something from these two measures? What is the distance between these two? The distance is nothing but 6 minus minus 2, which is 8. So that means your this distance is 8, which is equal to your this radius. That means if you try to visualize a bit, coordinate geometry is all about visualization. So if you try to visualize a bit, you can see that the circle L is nothing but like this. It goes like this and it touches exactly at this point and moves away again. So your this line x equal to 6 line is basically a tangent to your circle given by L, or the locus given by L. So what is this point? The question has asked only this thing, that what is the point, and the answer to your question is 6 comma 3. The locus L touches x equal to 6 line at 6 comma 3. And yeah, thanks for watching. If you like my videos, if you like the method of solving, Please do like, share and subscribe. Thank you. Hopefully I will be back with another such video tomorrow. Thanks for watching. Thank you. Bye bye.